So, my dear students, so far we have studied SR latch, both active high logic and active low logic. We have seen the issue in SR latch, which is invalid inputs. Now we are moving towards getting a latch without any invalid inputs. One such is a delatch. So we will see how delatch works, its truth table. Then we will proceed with how we can obtain various other flip-flops from the latches. What is the need for the flip-flop? We are going to look at. So let us look at the delatch. Now what exactly that we are trying to do is, here up to here we know. So far this circuit we have seen, which is SR latch. Now what we are trying to do is, we are combining S and R through an inverter. So if you give D is equal to 1, R becomes 0 here, S becomes 1 here. If you give 0 here, the 0 complement of 0 becomes 1, 0 will become the input. So what we are trying to do is, from SR latch, if at all you look in from the table, 0 0 no change, 0 1 1 0 1 1 1 1 is invalid, 0 1 reset, q 0 q bar 1 1 0 q 1 q bar 0. So this, from these two we are building a new device. This is the case of no change, this is invalid. So I don't want such an invalid case for my latch. So I am designing a new latch where I have the inputs are of only these two patterns. What is that? S is equals to 1, S is equals to 1, R is equal to 0, S is equals to 0, R is equals to 1. What we did? Instead of keeping them open, we are directly giving S as D and we are giving complement value to R. So when S is 1, R is 0. When you give the input 0, okay, so just what we are trying to do is, we are using only set reset properties of SR latch. So from set reset of your SR latch, we are deriving a new latch called delatch. I hope you understood. So rest is same. Because this we have discussed already, we need not discuss once again how this works. Only thing is how it is different. So how it is different is, I won't get both being 0, this is being 0, this is being 0. I'm not going to get. And this is being 1 and this is being 1, I'm not going to get. So these two cases are removed simply by putting an inverter, okay, combining S and R through an inverter in R, okay, resulting in delatch. That means what exactly? Now S and R are combined. There are no two inputs, so there is only one input. So of exactly D input, Q input, Q bar input. D1 means S is equal to 1, so it will set. D0 means it is reset. Why? If I give D0, complement of 0 becomes 1. So R is equal to 1 is happening, S is equal to 0 will be going. The same 0 will be there. Right? So D0 means you are resetting. D1 means you are setting. Okay? So it is going to reset, Q is equal to 0, Q bar is equal to 1. Now what is happening? Data even, whatever the data that is giving in, you are giving 1, you are getting 1. You are giving 0, you are getting 0. That is the reason why it is known as delay latch. D latch is delay latch. What is that? If you give 1, you will get 1. If you give 0, you will get 0. Okay? So this is how a D latch, which is derived from the SR latch itself, where both inputs being 0, both inputs being 1 is eliminated. Only setting, resetting is being done through a single input called D input, because whatever you are giving, that itself is the output. This is known as D latch. Okay. So the issue in the SR latch is removed by deriving a D latch from the SR latch. Okay. So this is what exactly the D output. In SR latches, okay, there are two varieties that we have seen, that is active high S and R latch, active low S and R latch, okay, then D latch. These are the symbols how exactly we represent latch, okay. So this is the truth table which I have explained already, where C is the control input, D is the data input, next state of Q, that is output of your flip-flop, latch, is when input is 0. Which input? Control input is 0. Doesn't matter whatever may be the input. What exactly happening? There is no change in the output. The value of Q is not going to change. When C is 1, C is 1 means control input is 1, latch is working. When input is 0, output because of the reset state. When D is equals to 1, okay, Q is equals to 1 because of the set state, which we have seen from the previous diagram, right? So next, we would like to use D latch as a storage unit. But latch is, whatever this latch is level sensitive. What is level sensitive? Is C is 0 or C is 1. What is C? Control. Based on C it is working. But level sensitive devices having a serious problem. What is that serious problem is? For a D latch, let's suppose D is 1, Q is 1. Okay. Now you would like to take this value Q is equals to 1. By the time you are taking Q is equals to 1, let's suppose D changes to 0, Q also changes to 0. So by the time you want to read this value as 1 but it is going to 0, now you will read as 0. Okay. So what is happening? What is being stored there is not constant. It is dependent on D. That means the value key whatever exactly we are looking for, okay, which we are getting from D, of course. And when you want to record that value, while recording, if D changes, then Q changes. So that is an issue. Why that is an issue? Because it is transparent. D changes, Q changes. I have seen some value with D. I would like to look at the output. I would like to copy that value. By the time I want to change, I want to copy this value, Q value. If D changes, Q changes. Okay. So that is the issue. For this issue to address, what we try to do is, instead of level triggered storage unit, we go for edge triggered. That means instead of in the clock signal like this, C is 0, C is 1, C is 0, C is 1 control signal. Instead of that, we can go for raised values. That is that 0 to 1 transition or 1 to 0 transition. Instead of level triggered latches, we can go for edge triggered flip-flops. So what we try to do is, we try to build memory devices which are sensitive to rising or falling edge of the control input. So the memory device which works based on the clock edge is known as flip-flops. Okay, so what we are trying to do is we are trying to derive flip-flops from the latches, where in this latch is going to change its value, okay, transparently based on the input. But whereas flip-flop, it changes its value only during the edges. If it is a positive edge triggered flip-flop, only from 0 to 1 transition will change the value. The rest of the time, it is not going to change. Once again, from 0 to 1 transition, based on the input and variety of the flip-flop, we are going to get the output. So, it is edge triggered flip-flop. So, is that fine? Next, what is the need for flip-flop? The need for flip-flop, just I told already that if you want to record the output, if you want to take the output, by the time input changes. So, as this control is level triggered, and as inputs are changing, outputs are also changing, okay, which I don't want. So for that, what exactly we try to do is we will go for edge triggered flip-flops on time basis manner. Actually, we are using clock is for what? Timing. So positive edge here, positive edge here, edge here, edge here. At particular timing instance only, we would like to change the flip-flop outputs based on the input and presence of the clock. Okay, so flip-flops are nothing but the memory elements whose operation is controlled by the clock signal. Okay, so the control input is purely positive edge triggered or negative edge triggering. Triggering means that supports particular operation. It initiates. Okay, positive edge triggered. Edge triggered means your triggering is initiating the operation, initiating the action. Okay, this is what exactly we try to look in. Of course, it can be a negative edge triggered. If it is negative edge triggered, it will be like this. If it is we are looking, if we are dealing with positive edge triggered, it will be like this. Okay. So the main idea is memory element should not respond as it's like. It has to respond at certain points of time. What is that certain points of time? I need to define. Okay, and how exactly it should be in synchronous with the clock, because in accordance with the clock, your circuit functionality in accordance with the clock edge, wherever the clock edges are there, okay, it is going to function. So that will give you the memory elements functionality based on timing, based on clock timing. Okay, so this is what exactly need for a flip-flop. From this we can go for designing of flip-flops. Okay, that we will see in the next class.